In the beginning, there was darkness. No planets, no oceans, no life. Only vast clouds of gas drifting through an endless, silent universe. Then gravity began to pull. Slowly, over millions of years, those clouds collapsed inward. Pressure increased, temperature rose. And deep inside the darkness, the first stars were born. Stars became the engines of the cosmos. They illuminated galaxies, forged the first elements, created the building blocks of worlds. And eventually, they created us. But stars are not immortal. Even the brightest star in the sky is living on borrowed time, because every star has a death waiting for it. Tonight, we journey to the end of a star's life, from gentle cosmic fading to explosions so violent they outshine galaxies, to the terrifying birth of black holes. This is the story of how stars die, and why their deaths may be the reason you exist at all. Far beyond Earth, hidden inside cold nebulae, new stars are forming right now. Gravity compresses hydrogen gas until the core reaches unimaginable temperatures, over 10 million degrees. At that moment, nuclear fusion ignites. A star is born. Fusion becomes a battle against gravity. Gravity pulls inward, fusion pushes outward. For millions, sometimes billions of years, the balance holds. This stage is called the main sequence. It is the longest chapter of a star's life. Our own sun is currently here, stable, predictable, quiet. But even now, the clock is ticking, because stars survive by burning fuel, and eventually, the fuel runs out. Deep inside a star's core, hydrogen atoms are smashed together. They fuse into helium, and in the process, tiny amounts of matter are converted into pure energy. That energy travels outward as heat and light. It is why sunlight reaches Earth, why plants grow, why oceans remain liquid, why life exists. But fusion cannot continue forever. Eventually, the hydrogen in the core begins to disappear. The star starts to change, and death begins. For stars like our sun, death comes slowly. As hydrogen runs low, gravity begins crushing the core inward. The core heats up dramatically, and the outer layers expand outward into space. The star transforms into a red giant, a dying monster hundreds of times larger than before. If our sun became a red giant today, Mercury would vanish, Venus would burn away, and Earth itself may be swallowed whole. The skies of Earth would turn blood red. Oceans would boil. The atmosphere would disappear. And the planet that once carried life would become a burned, silent rock. But even as the outer layers expand, the core keeps collapsing. Temperatures climb even higher. Soon, helium fusion begins. The star receives a brief second life, but this too is temporary. Eventually, the fusion stops forever. The outer layers drift away into space, creating glowing shells of gas called planetary nebulae, beautiful cosmic ghosts floating through darkness. At the center remains only the core, a white dwarf, a dead star the size of Earth with the mass of the sun. Its matter is so dense, a teaspoon would weigh several tons. No fusion, no fire, no rebirth. Only a slowly cooling ember, fading across billions of years. This is how most stars in the universe die, quietly. But massive stars meet a far more violent fate. Some stars are giants from birth, 10, 20, even 50 times more massive than the sun. These stars burn hotter, brighter, faster, and because they consume fuel at terrifying speeds, their lives are short.
A star massive enough may live only a few million years. Cosmically speaking, that is almost nothing. Inside these giants, fusion becomes extreme. Hydrogen fuses into helium, helium into carbon, carbon into oxygen. Then neon, magnesium, silicon, until finally iron forms in the core, and iron changes everything. Iron cannot release energy through fusion. The star has reached the end. Fusion stops, and in less than a second, gravity wins. The core collapses inward at incredible speed. Temperatures rise beyond comprehension. Shock waves erupt outward. And then, the star explodes. A supernova, one of the most powerful events in the universe. For a brief moment, a single exploding star can outshine an entire galaxy. The explosion races through space at millions of miles per hour. Anything nearby is destroyed. Planets vaporize. Radiation floods surrounding systems. But from this destruction comes creation. Because supernovae forge the heavy elements of the universe: gold, silver, uranium, calcium. The iron in your blood was created inside dying stars billions of years ago. You are literally made from the ashes of stellar death. Carl Sagan once said, "We are made of star stuff." And scientifically, he was right. But the story does not end with the explosion. Something remains. And what survives depends entirely on mass. If the core is small enough, gravity crushes atoms together so violently, electrons and protons merge into neutrons. The result is a neutron star. These objects are almost unimaginable. A neutron star may contain more mass than the sun, compressed into a sphere only a few miles wide. The density is beyond human intuition. 1 teaspoon would weigh billions of tons. Some neutron stars spin rapidly, hundreds of times every second. As they rotate, they emit beams of radiation into space. If those beams sweep past Earth, we detect pulses. These are pulsars, cosmic lighthouses flashing across the galaxy. Others become magnetars, the most magnetic objects ever discovered. Their magnetic fields are so powerful, they could erase credit cards from thousands of miles away. A nearby magnetar could even disrupt atoms inside your body. These are the strange corpses left behind after stellar death. But for the most massive stars, even neutron stars cannot survive. Gravity continues crushing inward, relentlessly, mercilessly, until space itself collapses and something terrifying is born: a black hole. A region where gravity becomes so extreme, not even light can escape. At the center lies the singularity, a point where physics itself breaks down. Around it exists the event horizon, the boundary beyond which nothing returns. Not matter, not radiation, not time itself. Black holes distort reality. Time slows near them. Light bends around them. Entire stars can be torn apart if they wander too close. Yet black holes are not cosmic vacuum cleaners. If the sun were replaced by a black hole of equal mass, Earth would still orbit normally. But without sunlight, our world would freeze into darkness. Black holes remain among the greatest mysteries in science. Some may contain answers about the origins of the universe itself. Others may connect to dimensions we do not yet understand. And at the center of nearly every galaxy, including our own, lurks a supermassive black hole. The Milky Way's central black hole contains millions of times the sun's mass. Silent, invisible, watching from the dark. But perhaps the strangest truth of all is that death is essential to cosmic evolution. Without dying stars, the universe would contain almost nothing except hydrogen and helium. No rocky planets, no oceans, no carbon chemistry, no human bodies. Every atom inside you was once inside a star. The oxygen you breathe, the calcium in your bones, the iron in your blood, all forged in stellar furnaces, all scattered through space by death. When ancient stars exploded, their remains drifted across the galaxy. Those materials formed new stars, new planets, and eventually, life. In a very real sense, you are the universe becoming conscious of itself.
Born from dead stars, looking back into the cosmos, trying to understand where you came from. And one day, our own sun will join this cycle. 5 billion years from now, it too will die.
The skies of Earth will disappear, the oceans will vanish, and the sun will become another white dwarf, drifting silently through the galaxy. But long after humanity is gone, new stars will continue to form. New worlds will emerge, and somewhere, perhaps around another distant star, life may once again look upward and wonder about the fate of the universe. Because in space, death is never truly the end. It is transformation. The destruction of stars creates the possibility of everything that comes next. And perhaps that is the greatest story the cosmos has ever told. The universe kills stars so that life itself can exist. And every night, when you look into the sky, you are looking at both the past and your origin. The story of dead stars is ultimately the story of us.